Effective pressure control of tanks is a vital component of safe tanker operation. The possibility of overpressurization or tank rupture due to underpressure developing in tanks is ever present during cargo handling. Either of these conditions presents a major hazard which threatens the structural integrity and safety of the ship. It is a critical function of the officers and crew on board a tanker to prevent these conditions from arising. Let's look at the problem more closely. The volume of an average cargo tank inside a modern tanker can be 12 to 14,000 cubic meters, easily accommodating a 6-story apartment block. The walls of this tank are likely to be constructed from steel plates of around 20 to 25 millimeters thickness. The shell thickness in relation to volume is not too dissimilar to that of a poultry egg. Is this good news or bad? You can answer this question yourself, depending on your own view of the pressure control procedures on board your ship. The task of pressure control is simple, but getting it right is complex as well as critical. Because this vast volume is filled with cargo, ballast or vapor, moving any of these in or out of the tank must be carried out so that the pressure inside the tank remains within allowable tolerances. If the internal pressure rises above the test level during ballasting, loading or internal transfer of cargo or ballast, the tank may rupture. If the internal pressure falls below atmospheric pressure, then the tank may collapse inward, with equally disastrous results. Maintaining the safe operating pressure inside the tank usually means that either the inert gas system on board ship is operated correctly, or that simultaneous ballasting is carried out at the correct rate during the discharge of cargo. In all cases, correct operation entails checking cargo rates, ballast rates, rate of ullage and soundings changes, and at all times monitoring the tank pressures. Are you familiar with the pressure control systems on your ship? Are they comprehensive? Are they effective in your view? Are you sure your safety installations, the PV valves, the pressure vacuum breaker, the deck seals, the mast risers, and the monitoring systems, are they well maintained and in full operating condition? During loading or ballasting, overpressurization of the tank can be caused by the compression of the ullage space due to the inadequate release of vapor or by overfilling of the tank by liquid. The result? Serious deformation of the tank structure and its peripheral bulkheads, possibly leading to catastrophic failure and fire. Typical operational causes for overpressurization are overfilling of the tank with liquid, incorrect setting of the tank's vapor or inert gas isolating valve, material failure of the isolating valve, choked flame screens, filling rate being faster than the vapour line can carry the vapour away. Ice forming on vents during cold weather. Ice on the surface of the ballast. Restriction in the vapour lines caused by wax, residues or scale. Under-pressurization can arise when the internal tank pressure is allowed to fall below atmospheric pressure due to incorrect setting of the tank isolating valve sited between the tank and the vapour line or inert gas line. Material failure of the isolating valve. The inert fan not running or inadequate IG supply due to failure or operational mistake. Material failure of one of the inert gas supply valves. Choked flame screen on the vapour inlet line. Ice forming on the ballast vents during cold weather. The remedial measures include raising the liquid level in the affected tank by running or pumping cargo or ballast into it from other tanks, or by admitting inert gas or air into the tank ullage space. If air must be used for reducing the problem, a great deal of care must be exercised to ensure that no static electricity can build up, nor foreign objects with a possible ignition capability, such as rust scale, are drawn into the tank. Controlling the pressure inside the cargo tanks function of the inert gas system in normal circumstances. All the cargo tanks on board are connected individually to an inert gas main running along the tanker deck. Where branch lines are controlled by valves, these are normally locked in the open position, equalizing the pressure in all the tanks at the IG mains pressure level. This can be verified by the individual pressure indicators if fitted. During loading, the inert gas plant should be closed down and the gas pressure in the tanks to be loaded reduced. Cargo should be loaded with the ullage ports, sounding ports and sighting ports securely closed. The tank which is receiving the cargo is expelling the inert gas and cargo vapour mixture into the atmosphere via the vent stacks or through high-velocity valves, or it is discharged into a vapour recovery system. Alternatively, the gases may be transferred through the IG mains into the other tanks. To prevent the pressure from rising above the maximum safe level, ballast is discharged from other tanks simultaneously, equalizing the pressure in the tanks and avoiding the need to discharge to atmosphere. During the discharge of cargo, the IG system is relied upon to produce sufficient volume of inert gas to replace the volume of cargo leaving the tank. If the rate of discharge is steady, the operating pressure inside the tank is maintained by supplying the right volume of inert gas to replace the cargo. Fluctuations in the rate of discharge should be matched by the variation in the inert gas pressure, that is, the volume of inert gas produced. If, for any reason, the IG system fails to produce the required volume of gas, either the cargo discharge rate must be reduced or the discharge stopped until the IG system is repaired. An alternative method of maintaining operating pressure in the tank being discharged is the simultaneous ballasting of another tank connected to the system via the IG mains. This also equalizes the pressure in the tanks. Probably on board most ships, the effective control of cargo tank pressure is achieved by a combination of the two methods. What is absolutely clear is that close monitoring of the IG mains pressure, as well as the pressure indicators attached to each tank connected to the system, is necessary at all times when cargo is handled. Therefore, there must be a method of recording the status of vents and venting valves which can be observed at a glance. Any changes in the status of any of the valves must be authorized by the chief officer. All this means nothing in terms of pressure control if the installation of the IG system, its monitoring and alarm systems are not checked and maintained properly. The initial checks on the proper functioning of the IG system should be carried out before the tanker reaches port. Regulations control this process, and this is dealt with in detail in Videotel's Operation and Maintenance of Inert Gas Systems. The main items to be checked for maintenance are the blower fans, the control valve, which separates the safety area of the deck from the engine room areas, the deck seal, the non-return valve, which prevents the mixture of inert gas and hydrocarbon vapor from entering the hazardous machinery area, the liquid pressure vacuum breakers, and the mechanical PV valves normally fitted to each of the cargo tanks. The pressure transmitters monitoring the system and gauges displaying the pressure in each individual tank where fitted should be cross-checked, as irregularities, such as a valve being closed on an inert gas line, can often be detected before damage occurs. That is why it is most important that all branch line valves are tested to be in the correct position by 2 people independently before cargo operations begin. These checks are part of the operational routine of the inert gas system on board the tanker. For example, besides periodic manual lifting of the PV valves, they require regular cleaning, and the valve seats require regrounding to ensure reliability. Before cargo operations begin, always check that the IG system operates correctly as described in the ship's IG manual. Always check that the branch line isolator valves are locked in the correct position. Always check that the PV valves operate correctly. As soon as you detect any abnormal pressure reading anywhere in the system, consult a senior officer immediately. For further information, please consult your ship's manual and the relevant ISGOT and OCIMF publications dealing with overpressurization.